Hello again. This is the second webinar in our series. In the first one, we looked at bitcoins. What are they? How do we use them? Wallets. We looked at privacy versus security. We went a bit beyond and looked at altcoins or alternative cryptocurrencies. I want you to go through that video and review it if you think it's necessary before you begin this one. And before we get into today's topic, I want to answer a question which I've been getting from a bunch of you. You asked if this content could be shared outside. Please feel free to do so. The idea of these sessions is to spread information, to spread knowledge. You have a public link on the Network Capital website, which you can share with your friends, with anyone who's interested. Getting into it, today's session, we're going to be looking at the technology that underlies all these cryptocurrency systems, something which is referred to as blockchain technology. Blockchain tech today is going into everything from portfolio management to real estate registries to bank trade finance. And because of all these applications, because of all these big words, because of all the talk and hype surrounding it, it can seem a little intimidating. I'm here to tell you that that need not be the case. I'm here to tell you it's very simple, it's quite straightforward, and using an analogy, we should be able to get an approximate idea of what a blockchain is. To begin with, I'd like to use the analogy of a train. A train has carriages. Each carriage has a certain number of people, of goods sitting inside it. Whenever there's a train station, you can add people to this carriage. When your carriage fills up with people, you add another carriage so that more information can be carried inside it. And this idea of a train with carriages with people is pretty much what a blockchain is. You have a blockchain, which is a chain of blocks. Each block has information inside it, just like a carriage has people. This information can be anything. It could be a record of how much money I'm sending someone. It could be your certificates. Anything which can be coded can be put inside this block as information, and you chain these blocks together to get a blockchain which exists somewhere in a public ledger. This idea sounds pretty interesting, right? It's a store of information. It's a way to link all the information together, but that's something which databases can already do. To go beyond this limited idea of people, carriage, train, to go to actually what a blockchain is, we need three main factors. The first one is that, let's say we're talking about financial transactions. If I'm sending money to you, this information, once it's recorded on the blockchain, it cannot be erased or edited, which means that all the information inside a block must be immutable or unchangeable. Once it's been recorded, it has to stay that way. The second thing we need is that, let's say I'm giving you money and you're then giving that money to somebody else and they're passing it on to a third person and so forth. This order of events needs to be maintained. This sequentiality matters, which means that when we add more information to a block and more blocks to the chain, it can only be added at the end. Not in the beginning, not in the middle, not at any random points, but it has to be added to the end so that your blockchain stretches from the beginning of time to the current day. When you have all this information, it needs to be recorded on the blockchain. The third factor is that you need somebody who you can trust to be adding the information. Because if I say that I paid you $100, somebody needs to say that yes, this transaction happened. These three factors together, these three are what make your train example into a blockchain. It's an immutable or unchangeable set of blocks which record information in order from the beginning of the system to current time, and these blocks are verified to hold accurate information. Immutability, sequentiality, verification. The first two steps are pretty much built into the technology, but for the third step, you depend on the blockchain's network, the network of peers who are using the chain. There are different ways of doing this signing, doing this verification. In Bitcoin, you have something called proof of work, where the miners who are mining the Bitcoin get to sign off on the blocks. In Ethereum, you have something else called proof of stake, where people who are owning a certain percentage of Ethereum get to sign these blocks. Or you could even think of the Ethereum proof of stake example as similar to what happens with voting in public companies. And through this, you have a trusted, linear chain of blocks, which everyone on the network has a copy of. So you have created a public ledger which holds the information for anyone to cross-check. And you have created a decentralized, in the sense that no single person controls it. You have created a decentralized public in that anyone can verify transactions, ledger, or a store of information. Now these aspects, the fact that you have a decentralized public trustless ledger, is what makes a blockchain actually have value. It means that you could be putting any sort of data on the chain. This data is arranged in order and it carries information about every single person who is on the network. You could put all your data, for example, from a financial system onto the blockchain. And by doing so, you will remove the need for a third party who is there safeguarding or verifying or guaranteeing this information. This is why you hear about the potential disruptiveness of blockchain technology in the financial sector. But a blockchain can do more. If your money is on a digital ledger, you can easily write some code to interact with this money. I could write a program that automatically pays my developer on the 30th of every month. And this developer could then write a program that automatically allocates 50% to groceries and 50% to settle her debts. And the person receiving this money can then automatically reinvest it into other cryptocurrencies. We can do all this without banks, without fund managers, without intermediaries or third parties, all because of a trusted, decentralized ledger, which we call the blockchain. And because all this is digital, we're in a position to be creating something quite unique, something which is come to be termed as a smart contract. These smart contracts are automatically executing contracts. They pull information on triggers in the world around them and they automatically do things which we've told them to do. For example, I could write a contract that is an escrow service between a supplier and a buyer. Let's say you're buying something from AliExpress. You have Alipay, which is an escrow service, but I could write a smart contract which checks the package and the delivery number with, let's say, the local customs office. And as soon as it is done, it can release funds to the supplier. You don't need a third party being in the middle anymore. I could even do something more complex, like create an investment fund where I say I'm raising money. And for the first X amount of money, I'm going to buy 10 Bitcoins. If I get more than this, I'll buy 10 Ethereum. And if I get even more, I'll buy 10 more Monero. In this way, I can create a fully digital hedge fund. And although this idea seems a little foreign and alien, it's already being put into practice. And you could put just any kind of information on this blockchain. You can put up records, you can put certificates, you can put identity proof. And once you have any of this on a digital system, you can connect it to other elements in the system. You can interact with it through smart contracts. Now, the blockchain sounds pretty powerful. It's sort of matured in that you see real life examples of the things I've described. You have countries like Georgia and Sweden testing out land registries. You have Google using blockchain tech for health records. You have portfolio management services that collect money from people in a fully digital hedge fund. And you have banks in every country which are jumping on the bandwagon. And to me, I apologize for a second, there's some construction work going on, so you're going to hear some noise. I'm going to try to speak a little louder to make up for it. Hope it's okay. What I was about to say is that this fact that you have every single bank in a country jumping on the bandwagon, this is kind of funny to me, because for something that's supposed to have been completely disrupting life as we know it, it seems to be taking quite a long time to go about it. I've been working in finance with blockchain tech for 3 years, and while I've seen the technological advances, the leaps, I've not really seen any disruption happening, and I've learned to temper my expectations. No doubt there are very cool applications for the blockchain, like with health records, like with registering migrants. But this doesn't feel like a technology revolution. It's not a leap as much as it is technology adaptation. For the majority of people, a nicely cleaned up spreadsheet is going to be more than sufficient. You need to keep in mind that huge financial institutions, whether it be banks or PayPal or investment companies, they have their inefficiencies. They are dinosaurs in some sense, but they are not stupid. Many of their costs are because of necessities. PayPal spends billions every year on compliance, on anti-fraud, and banks work with hundreds of databases, if not thousands, and it doesn't necessarily make sense to put all of this together under one roof. Blockchains have some great uses, but the tremendous complexity which a financial system entails means that a blockchain is not a catch-all solution. It means a blockchain is not going to replace banks themselves. The Bitcoin blockchain, for example, is many gigabytes of data in size. And if a bank were to have one, it would be terabytes or even 10 times as much data. And this is not the kind of thing that can even be on a public ledger. the current status of the technology, the way it has developed, does not allow for the kind of scaling you would need for a global implementation. And even for use cases which hold some value, for example, one common example I take is that if you had a public transparent blockchain, you could avoid cartelization. You could avoid the kind of scams like the LIBOR scandal of 2008. But the fact is that although it's possible, although a public ledger would reduce all this, you still need the banks to play ball. You need them to cooperate. And if all these financial institutions are busy building their own private blockchains, their own walled gardens, us, the public, are not really getting any more transparency. So in the name of adopting new technology, they can still be doing the same things the way they used to. The point I'm trying to make here is not that financial institutions are bad or good, but that the dream that everything will be on the blockchain, that this is as disruptive as the internet, that we will be voting for our governments on the blockchain, while possible, is not going to happen in the next 3, 5, or even 10 years. And if we don't change the human elements in the system, the factors which lead to transparency being necessary, to trust being problematic, to decentralization being demanded, if we don't change the basics, it doesn't matter what incremental addition we do using technology. And beyond all of that, I want to reiterate, if your needs can be met with a very well-organized spreadsheet, then maybe the blockchain isn't really necessary. I know I've been a little harsh on all the hype that is surrounding blockchain tech, but I hope the message you take back is the potential that all of this has. Imagine a decentralized, trustless digital system that every citizen can monitor, interact with, and help govern the world around them. That's the kind of future we could build, but it requires a lot of work. Over this session, I've covered what the blockchain is, how important immutability, sequentiality, and verification are for the blockchain, how it has uses because of being decentralized, trustless, and a public ledger, and how it would serve us well to not just give in to the hype surrounding it, but look at the potential uses of this technology. Like I said, the blockchain is essentially an easy concept to understand. And the importance of the issue lies in how you choose to implement it, how you utilize it. And that, I think, is what many people are now trying to solve, and that's where the importance of the technology lies. This session has been sort of tech focused. In the next session, we'll go back to cryptocurrencies and we'll be tackling the deeply fascinating world of crypto and capital investments. Until then, I look forward to answering any questions you might have in the upcoming FP session. I'll also be having a few links which you can use for further reading, which I'll be adding to the post. Thank you for watching this.